Okay, welcome everybody to Contemporary Issues here, the end of July. And we are going to talk today about UFOs and aliens and the possibility of alien life on other planets and even the theological implications of that. We can speculate and talk among ourselves about that since we are a church class. Here, Vicky's coming in here too. An alien life is coming over into my screen. There she goes.
Thank you.
Okay.
You picked me.
That's right. Well said. Okay. Well, our usual announcements, we're recording this today for future playback, and please mute yourself in the lower left corner of your screen when you're not speaking. And other announcement, we're having a summer get-together class party on Friday, August 6th. And we will have some food and drinks and games too. Fun at Ron and Alice's house. So I'm sending out an email about that. And I hope if you can join us, you can just come over for a while and we'll get together again. And then September 12, we'll be meeting in person here in the room, in the church. And that will be nice to see how many people come back. And anything else? Any other announcements? Anything going? Oh, did you want to talk about the money donation?
Yeah. Last week we talked about doing our $1 a day donation thing again for the month of August and donating that to the school supply fund that Ann talked about last week. So if any of you
Promise, I thought
was it Family Promise or Ann was talking about the school district too.
Okay.
So if any of you want to participate, you can either write a check at the end of the month for $30 or just put $1 in a day. It's kind of fun to do the $1 a day thing. I've been doing that. So whatever you choose to do. So also on the picnic, if when you RSVP, you'd let us know if your preference is chicken or burger or brat, that will kind of help us know how to purchase the meat. And then there's also an alphabetical division on what to bring for food. So hope you'll come.
Okay. All righty. Well, let's let Ron begin his presentation, and he will stop a couple times and let us discuss. And if you want to bring up topics like, did God create life on other planets, or would God create life on other planets? If you think he did already and we just haven't met them, well, let's talk about all those kind of things. Okay, Ron.
Okay, we're going to go to share screen. And let's see if we can bring up the one we want. Okay, can anybody see those comic book covers?
Yes.
Okay. Two of my favorite comics from when I was a kid. And of course, in the 50s, science was advancing quickly. The space rocketry was starting to take off, and interest in outer space and visiting other planets and all this started coming on, and it started feeding a whole industry of new topics for movies, comic books, sci-fi started to rise very, very quickly. So we kind of wonder what might alien life out there look like. And the one thing you'll see is most sci-fi writers show aliens as having 2 eyes, 2 ears, symmetry, and looking fairly humanoid, and that just might not be the case. Okay, here's another one. Calvin and Hobbes, for those that are Calvin and Hobbes fan, what would you call the creation of the universe? And Calvin says, the horrendous space kablooey, instead of the Big Bang. And I love that cartoon there on the bottom part of the screen. Sometimes I think the surest sign that intelligent life exists elsewhere is that it hasn't tried to contact us. Okay, next question. Okay, who knows what movie did this come out of? Let's see if I've dated myself outside of my audience. What movie did this come from?
Back to the Future.
Okay. And that was can you tell me what part of Back to the Future was that? Do you remember where this happened, this scene? Marty had just gone through the time barrier and crashed into that farmer's barn.
Yeah.
And the farmer came out with a shotgun to meet him there in the barn. Okay, we're going to start today by looking at our cosmic address. There's multiple strands of evidence, powerful evidence, not conjecture, guess. The Big Bang, which should really be called the Big Expansion, happened about 13.7 billion years ago. So the creation of our universe, or the existence of it, again, began about 13.7 billion years ago. If you're telling your postman, you're in a planetary mail system postman where you are, you want to, of course, say you're on Earth, you're in the solar system, and our stellar neighborhood has, within 20 light years of us, are 79 star systems. The nearest star that we can see is Alpha Centauri, which is a little more than 4 light years away. That means if there were intelligent people on Alpha Centauri and we sent them a message with our current radio wave technology, it would take more than 4 years for the message to get there and more than 4 years for a response to come back. Then, of course, we're in the Milky Way, and all the scientific literature I've said say we know we have at least 100 billion stars in our galaxy, and maybe as many as 400 billion. Most of the best scientists say probably 200, 300 billion. And our Milky Way, just our galaxy, is 100,000 light years across. So we can see with the speed of light, if we send a message out now, to get to the from one end of the galaxy to the other, it would take over 100,000 years. And then we're in a local group of galaxies, which is about 50 galaxies that have all joined the United Galactic Federation. And it's about 10 million light years across that. And then we're in a local supercluster with tens of thousands of galaxies. And it goes on and on. And just the observable universe, what we can see, has over 100 billion galaxies. So not only could they name a star for you, there was a radio advertisement years ago that talked about getting a star named for you.
Did?
You could get a galaxy. You could get a whole bunch of galaxies named for you. So that's it shows you really what a small part we are of the overall universe. Again, there's our Milky Way. It's kind of like a warped record. It does have I call it a disc-like shape, a little data on it. In our galaxy, we think that there's about 10 stars, 10 new stars born per year. So about one a month, there's a star birthday. We could have a birthday for our galaxy's latest new star about once a month. And so we're actually a fairly large galaxy. We're not the puniest one around. We're a spiral type, and we're larger than most of the other galaxies in the universe. So we're one of the big boys, our Milky Way. Well, I don't know how many of you, most of you have probably gone to a baseball game or a football game. And every once in a while you go to a game, and if you get there late, you miss the first inning or the first quarter, sometimes you miss the whole action. I think it was at a football game once in high school where somebody scored a touchdown on the opening kickoff. The other team scored a touchdown within 3 plays later, and that was it. There was no more scoring the rest of the game. To some extent, with the creation of our universe, most of the action happened in the first of the second. So I say if you miss the kickoff in the first 10 seconds of our after the Big Bang, you missed most of the action. And I won't go through all the things that happened, but you can see all these things happening in an incredibly short span of time. In 10 to the minus 43 to 10 to the minus 36 second, the gravity force broke away, and just all these things happening in intervals of time so small our mind can hardly pretend or imagine them. In the first 10 to the e to the minus 12 second, the basic four forces of the universe started going through their separation. And by a tiny fraction of a second, we went from one super force to four being the strong nuclear force, the weak nuclear force, the electromagnetic force, and the gravitational force. Okay, well, let's get over to something we call the Goldilocks zone. If you want to find life, you want to look for a star that can provide the energy. Life requires energy and heat. And you want to find planets or moons or planetoids that are in the range of an adequate sun. So we're kind of fortunate here on Earth, and our temperature to fall in a range of human life is controlled by, you need a sun that is approximately the right diameter. It's a giant nuclear fusion energy plant. It's pouring out energy. And ultimately, of course, everything on Earth depends upon that energy source for our very lives and existence. So we got to have a sun that's approximately the right diameter. The sun has to have the right burn rate. If you turn up the fusion rate too high, it throws out too much heat. And worst of all, it can burn itself out too fast. We'll talk about that a little more. And you've got to be roughly the right distance from your sun. If you're too far away, your planet's too cold. If you're in too close, you're all going to cook. And you also need your planet to rotate. If you want to think about it, if the Earth did not rotate or rotated at an incredibly low rate, you end up with one side that is a super cold, frozen place, and the other side is hot. And of course, the gases on the hot side of a non-rotating planet would evaporate, drift over the cold side, certainly the water would, and the water would all condense and freeze and form glaciers on the cold side. So you need energy source from your sun, but you need like a rotisserie, just like you have to rotate a rotisserie around if you want to grill the chicken on both sides, or at least flip them a lot. Our planet has to rotate at an acceptable rate to keep the temperature somewhat equal on both sides, and to prevent the big freeze out from happening and all the water collecting on the cold side. And then, of course, there's the final factor, and that's the greenhouse gas effect. Scientists have done the calculations and said, right now, Earth, if you stripped away its atmosphere completely, it would come, the surface of the Earth would come to an equilibrium temperature below the freezing point of water. So even though it rotates in the sun, it would not come to a temperature above freezing. And hence, we'd have frozen water on our planet and not things. So our atmosphere and the greenhouse effect of that atmosphere is critically important. It gives us we call it an atmospheric blanket. And right now, we humanoids are messing up that greenhouse blanket. We're putting too much CO2 in the atmosphere, and we're putting on too many quilts on the bedroom of Earth, and we're heating it up. It's not allowing enough heat to dissipate and get away from the Earth, and we're starting to make the bed too hot. So let's try to see if we can get rid of some of thin down that quilt. Okay, the chemistry of life. Is there anybody in the class that took organic chemistry as a college class? Okay, There's the Williams hands going up. Probably anybody in nursing and medicine has taken organic chemistry. The chemistry majors have. But we call carbon the element of life. Carbon is 10 times more abundant than silicon in the universe. And it is a marvelous element in that it has 4 electrons out there in its outer shell that are looking to mate with somebody. And it forms a lot of symmetrical bonds. And in fact, if you line up all the known chemical compounds known here on Earth, I think there's far more that are hydrocarbons, hydrogen, carbon, oxygen, than any other ones. And of course, every life form has, that we know of, is carbon-based and is based on, ultimately, carbon is a marvelous element. It makes long chains. It reacts, it forms bonds that are not so weak that they break with the snap of a finger, but not so strong that they can't react with other elements and keep the chains going. If you study DNA, the length of DNA chains is remarkable. If you, even inside a single cell, the DNA chains are incredibly long, tens of thousands. I don't have the exact number, but it's an incredibly high number of molecular bonds in a DNA. So carbon is truly the essence of life from an elemental standpoint. And that's why those that have taken organic chemistry will tell you how tough of a course it is. There's all these giant chains and trying to draw all the polymers and the chains and the right-hand, left-hand monomers and isomers and all this stuff. It gets pretty quick, but of course it's what enables complexity. Complexity means you can build a life form. Well, some people have said, how about silicon? How many in the class, I'm showing my age and of course my science sci-fi background, but does anybody remember, has anybody watched any of the episodes from the original Star Trek series? Okay, a few hands. There was an episode, a classical episode called The Devil in the Dark. And they went off to this planet and people were getting ambushed and killed in this mining tunnel. And they found a silicon form of life down in this mining tunnel on a distant planet. And it was called the Horta. And Spock does a Vulcan mind meld with the Horta and found out the Horta was in great pain because the miners were killing its bowling ball sized eggs. That was a silicon-based form of life. And so some people ask, well, gee, carbon's cool, but somewhat, I think right down below it on the periodic table is silicon. And silicon forms bonds pretty well. But the problem with silicon is that the bonds are so strong that it doesn't want to form additional reactions and additional products. So it takes one partner in a dance, but it won't make it a threesome or a foursome. There's a little chart here that shows the abundance of elements in parts per million in the universe. And you can see hydrogen and helium are way out in front. Oxygen's very high. But look, carbon comes in 1, 2, 3, 4th place in terms of abundance of elements in the universe. Silicon is down here 4th, 5th, 6th, 7th, 8th. So silicon comes in 8th, but look at that number, 4,600 versus 6,500, 650 parts per million. So again, carbon is an order of magnitude more abundant. So carbon's abundance and its ability to form bonds that are strong but not too strong makes it the element of life. So let's hear it for carbon. Okay.
Ron,
yeah,
question, if I could. We've
Sure.
not found, we've never yet found any other planet that has a carbon or a silicon or any kind of life, right?
Right now, we don't have any planet that we've found confirmed life on. We're getting more tantalized. In fact, it sort of sets us up for this next slide.
Okay.
On this slide are what scientists consider maybe two of the best candidates in our solar system to find life on. Jupiter's got a moon called Europa, and Europa has a slightly eccentric, that means a non-circular orbit relative to Jupiter. And Jupiter's gravity is so strong that as the planet gets closer to Jupiter, it gets squeezed, so it becomes less spherical. It becomes more like a hot dog, not that extreme, but it gets pushed out of its spherical shape as it moves closer to Jupiter. And then as it moves a little further away from Jupiter, Jupiter's gravity lets up some, not much, but it's enough that this moon Europa ends up like some bread dough that's getting kneaded. It gets squeezed when it comes closer and gets released a little bit. And that squeezing and releasing actually produces heat. And so Europa has heat from this gravitational kneading. And that happens in on several of the moons. If you look at our moon is so close to us, it's getting slightly kneaded by the Earth. It's not in a perfect circular orbit either. And so that does add a little bit of heat to the moon.
How about Mars?
And most planets have some moons that aren't perfectly spherical orbits. So this Jovian moon, in fact, we've now found out it has some geysers on it, okay? And here's a picture. This shows the Jupiter's moon, Europa, and it shows the geysers coming up. And I've got to look at the content of those geysers, but there's a good chance that there's some water ice and other ice that's getting melted by the kneading and the heat coming from the planet. And so Europa looks like a real good candidate. We think the Jupiterian moon, called the Jovian moon, has underground oceans that could have the chemical balance for life. And the radiation and the heat makes these internal oceans of Europa a good candidate place to look for possible life. And the same argument goes over to a moon of Saturn called, and of course Saturn has many, many moons, more than 60, but one of the larger ones, Enceladus, and here's a picture that some artist drew of some life forms swimming in that buried ocean within Enceladus. So scientists are very excited about sending some additional probes out to these respective moons of the planet Jupiter and the planet Saturn. And there's a good chance we could find some life there. How many have been to a national park here in the West with what we call thermophiles? There we go. And what is that national park, and where are those thermophiles?
Come on, folks.
They're in
Yellowstone.
Yellowstone, and those thermophiles are the extremely heat-tolerant bacteria. They're able to live in some of those scalding hot pools there at Yellowstone. Okay, we'll move over these slides pretty quickly. I've popped this one on the class before, the HR diagram, but I want to just quickly mention that I mentioned earlier, we need a sun that is the right size. It turns out we need a sun that not only puts out the right amount of heat, but a sun that will last a long time. There are some stars that burn out so fast, they're like a fireworks show. Of course, we're talking million years. But if a star only lasts 10 million years, that's hardly enough time to allow slow evolution and the emergence of life. So you need a star that hangs around for a long, long time. It's like an eagle sitting on an egg. The eagle, the sun, needs to sit on that egg for millions of years to allow the emergence of life. And the formula, for those who love math, lifetime of a star, it's 1 over the mass of the star to the 2.5 power. And that means if you want to have life, you don't want an obese star that's so big and burning so fast that it's going to burn out. You need as Conway Twitty sang in one of his songs, I want a man with a slow hand. Yeah, we need a sun that takes its time, doesn't burn too hot, and stays around. Okay. There's a satellite that's been put up called the Kepler Space Telescope. And it is discovering planets so fast, I can hardly keep up with it in the literature. It's now confirmed several thousand exoplanets, and that was data from 2018. It had already gone past discovery of 2,400 exoplanets, and it's discovered at least a double-digit number of near-Earth-size planets orbiting in their star's habitable zone. And one of the more exciting ones is this planet they've named Kepler 1649c. It's about 300 light years from Earth, and it's only 1.06 times larger than our own planet. And it receives about the right amount of starlight. We don't know a whole lot about its atmosphere, but it looks like a real good candidate.
So how long does it take to get there?
And the bad news is if you could have a spaceship that was traveling at the speed of light, it would take 300 years to get there. But this is a chart showing the number of confirmed exoplanets, and we can see it's in the hundreds. And it's really exciting. We're finding more and more every day. Okay, we're going to jump over to the Drake equation.
Oh, come on. Come on.
And this is a mathematical expression, and we're going to talk about the terms in it that talk about the probability of life. Drake came up with this equation, and it's got 1, 2, 3, 4, 5, 6 terms. N sub c is the number of communicating civilizations we could observe in the galaxy today. So we start off by measuring or estimating the number of stars, and we've got a much better estimate of that now than we did 50 years ago, a much better estimate. And we know it's over, like I said, between 100 and 400 billion, and that's just our galaxy. And when we multiply that times the billions of galaxies, we see what a big field of candidates we've got. I've talked to Steve, and I said, you know, and I've told the class this, I've said, in Denver metro area, there's over 2 million people. So if all of us has a probability of having a 1 in a million event happening in their lives today, that means 2 people in the greater Denver metro area today, on the average, are going to have a 1 in a million experience happen to them. And that kind of just gives us the idea, helps show us that if you roll enough dice and play enough cards, you're eventually going to have a lot of improbable things happen. Again, there's 2 people in Denver today that have experienced the 1 in a million experience. So when you look at how...
Ron, what's the bottom line on the Drake equation? Do they think it's likely or not likely there's other life?
Yeah, we think strongly. We've come in with our best estimates, and we think there's at least 25. Let's see, where do I get down? I put the numbers in.
Keep going.
25 planets with life?
At least, yeah.
Mm-hmm.
And I think it's higher than that. I think it's getting higher. We're getting better on these numbers as we gain more data. We basically look at, and I won't beat this equation to death, we look at the number of stars we have, and it's in the billions. We look at the fraction of stars that have a planet in the Goldilocks zone. And now, thanks to Kepler and some other data we've got, we're finding, yes, there are a good number of stars that do have are the right size, and there's some Goldilocks planets. And then, of course, the big question, what fraction of those planets that are in the Goldilocks zones and have favorable conditions develop life? And that's up for question. And then, of course, the big question is, how do we measure intelligent life? I think most of us, we're humans, we say, yeah, we're an intelligent planet. What if we discover a planet and the most advanced life form we can find there is an amoeba, or maybe some simple worm or something?
Ron, how are you defining life?
Okay, life defined by a metabolism, ability to reproduce, ability to, those are two of the key: metabolism, taking in energy, using the energy, expelling waste products, and reproducing is one of the key. And of course, how do we find intelligent life there? And how do we define intelligence? That's been the tougher one. In Neil deGrasse Tyson's book, he says, well, let's say ability to do algebra is intelligence. So, okay. So beating the Drake equation to death.
Yes, don't.
The fraction of planet F sub I is the, F sub L. The fraction of planets with life that develop intelligent life. And we think this is a small number. We're guessing that even if we discover 100 planets with life, the chance of finding intelligent life there is less than 10%. And then not only do you have to have intelligent life there, but the intelligent life has to have developed technology to communicate with us. So they've got to at least have reached the point in their civilization development that they've invented radio waves or some other, or laser beam, something to communicate. Clearly, if you put a listening device on Pluto at the time of the Civil War, the American Civil War, you wouldn't have heard any radio signals and you wouldn't have detected anything. But if you came back today, sat on Pluto, put your radio on, you would say, hey, there's WKRP there coming off of planet Earth. And then of course, there's the scary one. If you look at the whole history of Earth, we've made it to intelligent life, but the fraction of our planet's life in which we've had the ability to, for the intelligent life to emanate signals and send them out into the galaxy has just been a tiny, tiny fraction of the Earth's history. So you've got to come in, not only find the planet, but you got to find the signal during that narrow window. And there's real concern about the life of our civilization. Are we humans going to destroy ourselves? Are we going to be able to hang around for a million years without killing ourselves off sometime? Those are very philosophical questions. Okay. There's another comic book picture. You also have to, this deals with the development of intelligent life. Why the dinosaurs reigned for an incredibly long period of time on Earth. And so we have to ask the question, why didn't the dinosaurs develop into, or some kind of reptile develop into intelligent life? And we won't try to answer all that question other than to say they had a life form that was doing very well and was able to survive. And developing a higher intelligence didn't necessarily make the species survive better. There were other attributes that the reptiles developed that contributed to their survival better than developing a brain. So the brain isn't always the best thing to give you a better survival rate, depending on your world conditions. And it was a great Green Lantern comic book where some intelligent pterodactyls from a planet sent a beam to Earth, and they tried to spark evolution in the pterodactyls and let them take over Earth. Okay, we're going to move to the question and answer period in just a second here. Evidence of UFOs. You're hearing that there's a lot of UFOs evidence that's getting released now. I will say this, Roswell, they've definitely determined that Roswell was a high altitude sniffing balloon looking for isotopes being released by Soviet nuclear test. And it was a high altitude balloon with silvery chunks and pieces and instruments on it. And it came crashing down to Earth in New Mexico. And a lot of people thought, oh, it's alien. No, it wasn't alien. It was a secret military project they didn't really want the public to know about. Okay, let's throw a couple cartoons up there and then we'll get to our question and answer. I love these cartoons. Pretty cool, Dewey. Shake that jar and see if they'll fight. And the guy on the right, shoot, the aliens have stopped at the gas station. You've not only got the wrong planet, you've got the wrong solar system. Okay. I'll jump over the multiverse charts because, like I said, not only do we have to think about life in our galaxy, we've got to think about all the other billions of galaxies, and then maybe there's billions of multiverses. So it goes on and on. So a couple more cartoons I love. This one here, wonderful, just wonderful. So much for instilling them with a sense of awe as the guy's falling down the stairs. And then this guy here, inadvertently, Roy dooms the entire Earth to annihilation when in an attempt to be friendly, he seizures their leader by the head and shakes vigorously.
Pulled his head off.
Okay, yep. So let's get to our response. So let's put these question outs here. If we did acquire incontrovertible evidence of intelligent beings visiting Earth, what would we do? What would the alien motivations be for visiting us? Steve, you mentioned you saw a movie where they said the phrase, "We've come here to serve Earthlings." And you said, what did it mean?
That Twilight Zone episode, they came here to serve us as food to each other. Right.
Oh.
Yep. Ron, can we go ahead and start some question answer and commentary? Yeah. What's everybody think about likelihood of UFOs being alien life visiting Earth? I'm curious what everybody thinks. Dr. Bob, how about you as a medical person, a science person? Do you think aliens are visiting Earth?
I seriously doubt it. Like Ron said, the likelihood that an intelligent life form could last long enough just to get here from where they came from, given the limitations of the distances, highly unlikely. And the life forms could be totally different than anything that we know of as life forms. You know, it might be silicon based or some other base.
I have a nephew who's in the Air Force. He's actually in the Space Force section of the Air Force working on satellites and things. And he was telling me that he thinks that all these recent sightings are probably Russian or even our advanced drone technology. Then we just aren't admitting it, you know, and we've advanced farther than we're going to explain to the public because we don't want to give away our technological secrets, and that even our government doesn't know what we're doing because there are so many secret programs going on, and one side doesn't tell the other side of the government what they're doing. So that's his opinion.
Well, I have a question, and that may have already answered that question, Steve, but do we know any information about all the sightings that were taking place up in northern Colorado during the past year? The lights that were
the lights in eastern Colorado where the farmers saw lots of lights. Right. I think that was never determined, last I heard. But they think it was drones by companies, maybe searching oil and gas possibilities or something like that. But last I heard, they had nobody that admitted that, and there was no answer.
They are putting up some incredibly large arrays of dozens and dozens of mini satellites the size of shoeboxes, and those are sometimes being seen from Earth. So we're putting more and more stuff up there. Also, there's the ability to shine a laser beam from outer space down to Earth and back. I know the Air Force has, for several decades, been doing experiments to try to shoot down a aircraft with a laser beam from another aircraft. In fact, there's a test bed aircraft. I think they took an old Boeing 707 and converted it into a laser beam aircraft to fire at other aircraft. I also want to say, it's kind of interesting. We have found, I think, hundreds of these unexplained lights and beams and even some small objects, it seems like. But we always get close, we get tantalized, but we keep getting these almost there pieces of evidence, but we never get to that over the goal line and get a really undeniable, incontrovertible piece of evidence. We keep getting dozens, even hundreds of these almost, maybe, possiblies. And I think by now, the mathematical odds would have said, you know, we'd find remains of a spaceship or something like that, or a really undeniable visitation where the alien appeared to us in church service this morning.
Well, I think, Ron, there's been a lot of good discussion lately because of that UFO report to Congress. It stimulated some good questions. And of course, that came out and it didn't say anything new. It just said, we don't know what these are. They're likely somebody else's technology besides ours. But it did spur good questions about what would happen if, like you asked, what would happen if we really were contacted by aliens and we had some evidence that there was on other planets. What do you think, Ron? What's your thoughts on that? How would it how would it change our thinking or our science, or what would be different if we knew there was other alien life?
If they were advanced enough to be able to get to us and communicate with us, and again, travel to us, overcome seemingly the laws of physics as we know them, to beat out that light year displacement, we better hope they're friendly. Hope that their moral precepts have advanced as far as their technology. Otherwise, there's no doubt in my mind, if they have the technology to get here and they're mean, we've had it.
Yeah. Like so many movies have shown, the Independence Day movie and others.
Yeah.
I like your second question there too, Ron, on the screen now. Would Jesus have to schedule his birth and crucifixion on other planets? Good question. Would God and Jesus appear to others, and what would their religious thoughts be like? Would they be born in sin and require getting saved? That's good.
Yeah, the theological aspects are pretty complex. If you start, well, wait, what if there's 10,000 other planets? Does that mean, yeah, it starts getting sticky in a hurry. Of course, the theologian here would contact the one on the planet Zudar and say, well, Jesus was crucified here and that covers you guys over there. He doesn't have to come to your planet and visit and be born in Zudar, Bethlehem, and go through that again.
Good point.
Or, of course, heaven could answer back and say, well, we've got lots of Jesus clones. We'll just send one your way and make him fit the life form that your planet has. So excuse me for my irreverence, but it obviously creates some interesting head scratching.
Yeah.
My real fear is that we are going to find some forms, low forms of life, bacteria perhaps, or something similar to bacteria, and bring them back on some of our return ships and then not be able to deal with them.
That is a scary thought, Dr.
And they've
Bob.
kind of done that. They isolated the first Apollo astronauts when they visited, when they came back from the moon.
But they didn't isolate their capsule.
Right.
Yeah.
So maybe it's too dangerous to go exploring in the universe. Maybe we should stay home.
Yeah. If you thought COVID-19 was bad, what do you get? Wait till you bring back Europa or Enceladus 19 from Jupiter and Saturn's moon.
Or something.
Interesting. Does anybody have any friends or relatives that are firm believers in aliens and that we've been visited, or people have been abducted, that kind of thing? Nobody's jumping out there. There's a lot of people that do believe it.
Who was the famous? Sorry, Steve.
Go ahead, Alice.
Go ahead, Alice. Go ahead.
I was just
my
going to.
thought has always been that, if God is big enough to create and do what He's done here, aren't we a bit arrogant to think that we're the only ones that He has created? That's just Alice's simple little brain with faith, and that's my thought. And
I'm with you, Alice. I think there is other life out there. They're just too far away to have got to us, or we aren't smart enough to know that they visited us or whatever that is. But I think I'm with you. I think there is other life out there.
And I'm married to this scientist, so it's like we go back and forth.
Mm-hmm.
I may be wrong, but I think the LDS theology teaches that Jesus came over to North America and visited some, ancient white race people that inhabited upstate New York and other places, and actually made a visit. So Jesus had an earthly calendar and made visits to some different places.
I remember something about that too. The Mormons and aliens have some belief crossing over there. Does anybody know about that?
Yeah, and they believe that the prime God, they're really polytheistic, lives on the planet Kobe or something, and that if you really give a good life, you might get transported to that other planet, or to your own planet, and get to start your own little cool civilization. So, and certainly Scientology. I know very little about Scientology, but they certainly have a strong alien connection from what I understand.
Well, there are all those parallels between theology and science fiction, and that God lives in another dimension and is kind of an alien to us. And it is a whole study of interrelated thoughts. We sometimes don't want to admit that, but there is a lot of crossover, I think.
Susan, what were you going to say earlier?
Oh, I went to school in Boulder, the University of Colorado, and I remember there was a really famous astrophysicist that was a believer. And I was wondering, Ron, do you know who that was, or does anybody? We used to drive by his house all the time and remark about it. Yeah. Oh, I see somebody speaking, but she's on mute. Wanda?
Wanda, you're muted.
She's on the phone.
That's my grandson, so I don't not answer that,
Sure.
I will put in a plug for Neil's books. His book, Cosmic Queries, has just come out in the last 6 months, and it looks into a lot of those questions. And then, of course, there's a book by Neil deGrasse Tyson and 2 of his cohorts, and it's a fascinating science book called Welcome to the Universe. And it is a whole chapter on the Drake equation and the probability of extraterrestrial life.
Ron, what did Carl Sagan think of the possibility of extraterrestrial life, or Isaac Asimov?
Oh boy, well.
Any thoughts?
I actually haven't read much of Carl Sagan, so I can't.
One of my favorite books on my all-time list is Contact. It's a very good book. It's also a good movie if you're not a book reader, but it's an excellent book.
Yeah, wasn't that Jodie Foster where they set up the big radio antennas and
Matthew McConaughey
and got mathematical signals from outer space that they figured had to be alien communication.
But the book was better than the movie. Always.
The book was better.
I recommend reading it. It's a fun read.
Are there any other movies alien type movies that are favorites of people? I always liked the movie Alien.
Scary. Yeah.
Or Star Trek, Star Wars, anything like that. I enjoy watching.
My son thinks we're all in a simulation. That's his alien theory.
Yeah.
So we play the whose simulation are you in today game. And then, of course, his master one is that there's alien. We're all in a simulation and being controlled by aliens.
Oh, neat.
Teenagers are controlled by aliens.
I personally think I've got to be in Jerry's simulation. But my life might look different if it were my simulation. But yeah, but no, that's Ethan's big. We love to play that game. Like, whose simulation are we in?
That's funny.
What was the movie where they what was the movie where they communicated by music, and it was I think Richard Dreyfuss was
E.T.
No,
They landed.
no,
They
not
did the
E.T.
signals. They did the
Strange Encounters
musical.
of the Third Kind.
Yes.
Oh,
Yes.
Devil's
Yes.
Tower.
Yeah, that was good. I liked that. And I'm not a sci-fi person, but that was good.
But that does make sense to us laymen too, that they would, aliens would try and communicate with us through mathematics or musical tones or something. They probably don't speak English or French. So it's always fun to think about those kind of things. How would it actually happen? How would they actually communicate with us?
I loved the X-Files, if anybody remembers that TV show. We binged watched it recently. It's really good.
I saw a column just a few days ago in New York Times that had the headline, "I created the X-Files, but I don't think aliens are really here yet." So Chris Carter had written, who created the X-Files, said he'd been looking at all this and he believes they're out there somewhere, but they're not here yet. It was a good column.
Incidentally, we're so constrained by the speed of light, but I do want to point out one thing I forgot to highlight. The Big Bang is better called the Big Expansion because in that first couple microseconds, the universe did expand faster than the speed of light. It expanded much faster than the speed of light for a few picoseconds. And it was, the Big Bang is better called the Big Expansion. So it was a super rapid expansion. But within a fraction of a second, the physics that we know took over and limits us to the speed of light. But the speed of light is such a barrier to try to overcome to contact or reach. Like even that planet that's Alpha Centauri, that's only 4.35 light years away. That's a tough call to try to get there for us. Yeah.
Well, it's 11:30 on my phone. And any final thoughts before we ask Ron to wrap up?
Live long and prosper.
That's right.
I'm not sure I can do that. I've got to. I can't do it with my.
Yeah, that's good. Anybody else on here Star Trek fans besides Ron and I that really watched the series and enjoyed the concepts? I thought it was a lot of fun just from a mental and learning and envisioning aspect. You know, it taught us to think what other places would be like and other civilizations. And there's a new one, you know, they're filming a new Star Trek series now that starts in the fall that goes back, is the prequel to the original Star Trek with Captain Pike and the original Enterprise. And so there's a lot of excitement about that to see how that's going to show up on
the filming stage, you said. So
yeah.
Okay.
I think it starts this fall or winter.
Okay.
And they're filming in Canada, in Toronto, I think. Yeah. Well, thank you, Ron. Any final thoughts? Any final thoughts on extraterrestrials or UFOs? All righty. Well, thank you, everybody, for being with us. We'll see you next week.
Thank you.
Take care.
Thank you, Ron.
Thank you. Bye-bye.
Okay.